All right, so I watched this video today about do tire balancing beads actually work? And there wasn't like a easy conceptual, I guess, rule of thumb in this video that tells you intuitively what should happen. However, I think I know one, so I'm going to try to explain that here. But first, I'm going to watch part of the demo, and then I'll explain what's going on, and then I'll watch the rest of the demo, and then I'll finish off explaining what's going on. So let's start with the demo.
Some people think that this wild motion is the thing that moves the tire balancing beads into the right position to balance the tires. That means that if I was to pour some beads in here, it should balance this little cup of mine. But look, the beads rush to the heavy side of the cup, which just makes the problem.
I can't really draw on this, but you can kind of see all the beads, well, he's literally saying it. All the beads are on the same side as, all the free beads are on the same side as the heavy weight, which you can see is on the outside of the disc. He taped it onto the outside of the disc, and you can see all the beads went to that location. So let's use my plot here and explain why. It's not my plot. Found it online, but it's very, very good. Specifically, we're going to be focusing on this part of the plot. Okay, so he's at low speeds. Right now, he's spinning it at low speeds. So what's going on here? X-axis is speed, and the y-axis is phase, and vibration displacement, but we're not going to worry about that. So he's at low speeds. Specifically, he's going to be at below the critical speed, but we'll get to that in a couple of minutes probably. So let's assume he's right here. He's spinning it at a super low speed. What does this mean? What does a zero phase angle mean? Well, he's got, that's a terrible circle. I don't know if there's a tool on here that automatically draws circles. I don't know. But okay, so you've got, I don't know. So you've got the circle. He placed his external weight, let's say right there on the outside. So this is the heavy spot. Wherever the excess weight is, it's called the heavy spot. And that makes sense because that place is heavier. Or if you like carve out some material, which car wheels and a couple other things do this sometimes. They carve out some material instead of adding material. So they can carve out the material, and that places the heavy spot on the opposite side is where they carve it out. So anyways, you got the heavy spot, which is where you place the extra weight, effectively where you place the extra weight. And then you've also got the high spot. So there's the heavy spot and the high spot. Equals where you place the weight. Oh. I'm going to put this in quotes because some places remove weight, and then the heavy spot's at the opposite point of that. And then there's a high spot. And for the purposes of this demo, I'm going to define the high spot as where free marbles would end up. Free marbles. That's the best free I've ever written. So in his demo, he's at low RPM. So right down here. And his high spot and heavy spot have a 0 phase angle difference between them. And that means that the high spot, you know, I'm gonna say that's yellow and this is green. So the high spot and the heavy spot should be at the same, it's another color, blue. Yeah. Well, okay, let me define phase angle. So phase angle is an angle between these two spots. So if you had the high spot up here and the heavy spot down there, you would have a phase angle of maybe 45 degrees. But in this case, at low speeds, below the critical speed, but again, we'll get to that, the high spot and heavy spot are in phase, so they have a 0 degree difference between them. So they're both in phase with each other. There's no angle difference right there. Now, as he speeds up, what happens?
And worse. And honestly, that's what I imagined would happen, which is why I assumed that tire balancing beads were a scam. But here's the weird thing. If I spin the cup faster, suddenly the movement changes. Instead of flailing around, it smooths out. It's still unbalanced. You can see that wobble in slow motion.
Really quick right here. I guess we could start the talk right here. So you can kind of see the center of mass now looks like, well, the high spot looks like it's on the opposite side of the weight. I'll play it again for a second, but you can see the weight's on the top right, and that's the heavy spot, and the high spot looks like it's on the left, like the bottom left area, just by the way it's spinning around.
But it's much tighter.
Look at that. And that is, I guess, how we could start the rest of it, the rest of the conversation. So low speeds. These are in phase. Heavy spot and high spot are in phase. At high speeds, above the critical speed, now we're down here. And there's 180 degrees of phase difference between the high and heavy spot. Pretty neat, because that's literally what we just saw. But let me draw that out. Green is a heavy spot, so that's where we put the weight on the outside. Yellow is a high spot, so that's the part that sticks the farthest out from the central spinning axis. And there's a 180 degree angle between them. 180 degrees. Okay, that is literally it. But what happens next? So now that the high spot is on this left side, and we define high spot as where free marbles will end up, what would happen when he pours the marbles in? The marbles should end up on the yellow spot, on the high spot. And that is what happens.
And now when I add the beads, look, it balances perfectly. So what changed?
What changed exactly? Well, the thing that changed is he went above the critical speed. But let's just finish the marble talk. So when he pours marbles in, the marbles are going to want to go to the high spot because that's the part that's farthest out from whatever central axis it's rotating on. I'm not going to replay the video. Maybe I should replay the video now that, wrong thing. Now that we got that far into the discussion.
It's the thing that moves the tire balancing beads into the right position to balance the tires. That means that if I was to pour some beads in here, it should balance this little cup of mine.
You can kind of see that the more beads he poured in, the higher that the high spot became at the low speed scenario. And that makes sense because the beads go to the high spot, and at low speeds, the high spot's in phase with the heavy spot. And the heavy spot's already heavy. So you're adding more weight to the heavy spot, making it an even higher high spot.
But look, the beads rush to the heavy side of the cup, which just makes the problem worse.
Yeah, so this is low phase because heavy and high spot are in the same place.
And honestly, that's what I imagined would happen, which is why I assumed that tire balancing beads were a scam. But here's the weird thing. If I spin the cup faster, suddenly the movement changes. Instead of flailing around, it smooths out. It's still unbalanced. You can see that wobble in...
Yeah, and this is where you can see he didn't add any beads yet. And you can already see that the high spot, which right now is on the bottom, is the opposite of the heavy spot, which is right now on the top because the weight is up there. And you can see it just by the way it's spinning around.
Slow motion, but it's much tidier. And now when I add the beads, look, it balances perfectly. So what changed? To figure out what's going on, let's just try and...
Yeah. And then he goes into more detail and he shows that the beads will go to wherever the high spots are and cancel out the opposing heavy spot. So just like that. Yeah, so what'll end up happening over here, like I just said, is the marbles will go to the high spot because that's the farthest out from the center. And at high speeds, that is at 180 degrees phase difference, so the opposite side, as the heavy spot. So what happens when the marbles end up over here? Well, they cancel out the weight of the heavy spot. So now there is no heavy spot at high speeds. And that's why it balances perfectly. That's pretty sick. It is pretty freaking sick. Yeah. So what is a critical speed? Well, the critical speed is where, let me change the color. It's right where you're at 90 degrees between the heavy and high spot. So at the critical speed, the circle would look like, wrong one. Green is first. Heavy spot, high spot would be there. So there's 90 degree difference between them. 90 degrees. Here there's 180 degrees, and here there's 0 degrees. That's a good thumbnail. Yeah. So, how do you calculate this critical speed number? Well, I did some research online, and it's kinda, I haven't found a convincing equation that does it. So the way you do it experimentally is you'd spin this up, you'd put a heavy spot, like you'd put a weight, and you'd slowly spin up the mass until you can visually see that the heavy spot is 90 degrees from the high spot, because that is the location, or that is the definition of critical speed, is when the heavy spot and high spot are out of phase by 90 degrees. Because you're right there. But yeah, that is about it. All right, just a quick note. So, a lot of rotating equipment, whether it's like a drive shaft or like a pump shaft or whatever it is, has to be able to have low vibration at low speeds, so 0 phase angle, at the critical speed, so 90 degree phase angle, and at high speeds, so at 180 degree phase angle. And you have to balance the shaft differently to get through each of those stages. So, for example, let's say whatever you're working on, it is having high vibration at high speeds, so when it's 180 degrees apart. So to draw that out, let's say that's your, that's terrible. That's your shaft. It's still terrible, but that's fine. And you've got your high spot. You've got a really high spot, let's say right there. Well, first of all, what does that tell you? That tells you, since you're operating at high speeds, there's a 180-degree phase difference between the high spot and the heavy spot. So that tells you that there's a heavy spot, which is green, on the opposite side. So how do you counteract that? How do you balance for high speed? Well, what you would do is you would have to add some more weight on this side, because I'll draw it at a slightly different location, because this will add a high spot on the other side, and this will all cancel itself out. Yep. But let's say you're going through what kind of this plot is showing, where you are not getting through your critical speed. Let's say your vibration limit is right there, and you can't get through it. Whatever your device is, it trips, it turns itself off because it's too high of a vibration right there. And you're trying to end up like over here or something. What would that look like, and how would you balance for that? So, kind of doing this on the spot, but that's fine. I suck at drawing circles. Yeah, okay. So you have your high spot, and that's the location of high vibration. And you've got your heavy spot, which is 90 degrees from the high spot. So what would you do? Well, you'd want to add a countering high spot on the opposite side. To do that, you'd add a counterweight on the opposite side. Yeah. Okay. Well, I guess it's all pretty straightforward then. You just always want to add weight on the opposite side, which is why if your shaft is perfectly balanced, you will not have any vibration issues. But no shaft that is machined is ever perfectly balanced. So, yeah. All right, cool beans.